We have our function f of z, and we're told that 1/2 minus I root 3 is a root of that equation. Therefore, we know that the other complex root of the equation will be the conjugate of that. So it will be 1/2 plus I root 3. Now, I can use those two roots to work out the quadratic factor of that cubic. I know it's going to look something like z squared plus something z plus something. And I know that the coefficient of the z here will be minus the sum of these two roots. So the sum of those two roots is 1. So therefore I know that a is minus 1. And I know that the b on the end here will be the product of those two roots. So let's multiply those out. So the 1/2 times the 1/2 is 1/4. We know that multiplying these two together will cancel out with multiplying these two together. And so I just now need to multiply these two together, which would be minus I squared times 3. The I squared is minus 1, so just plus 3. 1/4 plus 3 is the same thing as 13 over 4. So that's my b value. So that's the quadratic factor that goes along with those two complex roots. To make my life a little bit simpler, I'm just going to multiply that quadratic factor through by 4 just to remove that fraction, remove the 13 over 4. And now I just need to find out how many times does that go into the cubic to get the third factor. The 4z squared goes into the 8z cubed 2z times. Multiply that out. The 2z times the 4z squared is 8z cubed. The 2z times the minus 4z is minus 8z squared. And the 2z times the 13 is 26z. We'll take that away. And we'll get a 20z squared, a minus 20z plus the 65. Repeating that process, the 4z squared goes into the 20z squared 5 times. And multiplying that back out, the 5 times the 4z squared is 20z squared. The 5 times the minus 4z is minus 20z. And the 5 times the 13 is 65. And we can see that thankfully gives us 0 as our remainder, so we know that we've done that correctly. And therefore our function f of z can be written as the quadratic 4z squared minus 4z plus 13 multiplied by the 2z plus 5. So our three solutions then, we've already got the 1/2 minus I root 3, the 1/2 plus I root 3, and our third solution comes from the linear factor there, which is going to be minus 5 over 2. So those are the three solutions to that cubic equation. Part C says that we need to draw those on a Argand diagram. So let's do that. There's my real axis. Here's my imaginary axis. So the first root, the 1/2 minus I root 3. Here's 1/2 roughly there. The minus I root 3 will be down here. The 1/2 plus I root 3 will be there. And the minus 5 over 2 will be roughly there. Part D says we need to show that these roots form the vertices of an equilateral triangle. So each of these roots is the vertex of an equilateral triangle. Different ways we can show that this is an equilateral triangle. I think probably the easiest way is to show that all of the sides are the same length. So side 1, that's going to be the difference between two complex numbers. So side length 1 will be the 1/2 plus I root 3 minus the 1/2 minus I root 3. The 1/2s cancel out and we just get 2I root 3. So the distance, the length of that side of the triangle is just 2 root 3. Side length 2, the length here, well, I can do that with a little bit of Pythagoras. So the bottom there, the length there, we can see that this is minus 5 over 2. This here is 1/2, so the difference between those is 3. The height of this triangle here is root 3. So we'll have 3 squared is 9, the root 3 squared is just 3. So that's root 12, which is the same thing as 2 root 3. Side length 3 will be exactly the same as that by symmetry. Therefore, we have an equilateral triangle with side length 2 root 3.